Lesson: AI-powered debugging and maintenance. AI-powered debugging and maintenance have revolutionized the way software development is approached, offering unprecedented efficiency and accuracy in identifying and solving problems. As a critical aspect of modern software engineering, AI-driven methodologies are not only streamlining the debugging process, but also enhancing the overall maintenance of complex systems, making them indispensable for professionals aiming to excel in the field of AI architecture. This lesson will delve into actionable insights, practical tools, frameworks, and step-by-step applications that professionals can implement to address real-world challenges effectively. One of the primary benefits of AI in debugging is its ability to automate the identification of bugs, significantly reducing the time developers spend on manual code inspection. Machine learning models, particularly those trained on vast codebases, can predict and identify potential bugs by learning from historical data. For instance, Facebook's AI tool, SapFix, autonomously detects bugs and generates fixes, drastically reducing the time developers spend on debugging. SapFix operates by using a combination of static analysis, dynamic analysis, and machine learning to suggest potential fixes, which developers can then approve and deploy. This approach not only saves time, but also increases the accuracy of bug identification, as the AI tool can process vast amounts of data far quicker than a human could. Another practical tool that exemplifies the power of AI in debugging is DeepCode, a platform that uses AI to provide real-time code reviews. DeepCode's AI engine scans codebases to identify issues such as bugs, security vulnerabilities, and performance bottlenecks, providing developers with actionable feedback. By leveraging natural language processing and pattern recognition, DeepCode can understand the context of the code and provide suggestions that align with best practices. This tool is particularly useful in large projects where manual code reviews can be time-consuming and prone to human error. AI-powered debugging tools are not just limited to identifying bugs, they also play a crucial role in code maintenance. Machine learning algorithms can analyze code changes over time, identifying patterns and predicting potential areas of concern. Continuous integration and continuous deployment pipelines often integrate AI to monitor and manage code changes automatically. For example, Google's tricorder system provides developers with immediate feedback on code quality, potential bugs, and style violations. Tricorder uses a combination of static analysis tools and machine learning models to provide developers with actionable insights directly in their development environment, fostering a culture of constant improvement and proactive maintenance. A key framework that aids in AI-powered debugging and maintenance is TensorFlow Extended, which enables the deployment of machine learning models in production environments. TFX supports the entire machine learning pipeline, from data ingestion and validation to model training and deployment. By using TFX, developers can automate the process of identifying and resolving issues within machine learning models, ensuring they operate efficiently and accurately. This framework is particularly beneficial in environments where AI models are integral to product functionality, as it provides a robust infrastructure for model management and optimization. Real-world examples illustrate the transformative impact of AI in debugging and maintenance. Consider the case of Uber, which employs AI to predict and mitigate system failures in its distributed microservices architecture. Using machine learning algorithms, Uber's engineering team can identify patterns in system logs that precede failures, allowing them to preemptively address issues before they escalate. This proactive approach not only enhances system reliability, but also reduces downtime, ultimately leading to a better user experience. Despite the advantages, integrating AI into debugging and maintenance processes is not without challenges. One significant hurdle is the quality and quantity of training data required for machine learning models to function effectively. Insufficient or biased data can lead to inaccurate predictions and unreliable results. To mitigate this, organizations must invest in curating high-quality datasets that represent the diverse scenarios their systems may encounter. Moreover, the interpretability of AI models is crucial, as developers need to understand the rationale behind AI-generated suggestions to make informed decisions. Furthermore, the integration of AI tools into existing workflows requires careful planning and execution. Organizations need to ensure that their development teams are adequately trained to use these tools effectively. This involves not only technical training, but also a cultural shift towards embracing AI-driven approaches. Encouraging collaboration between AI specialists and software developers can facilitate a smoother transition and maximize the benefits of AI integration. Statistics underscore the impact of AI-powered debugging and maintenance. According to a report by McKinsey, companies that have adopted AI in their development processes have seen a 30% reduction in debugging time and a 20% increase in code quality. These figures highlight the tangible benefits of leveraging AI, making it a compelling investment for organizations aiming to enhance their software development lifecycle. In conclusion, AI-powered debugging and maintenance are reshaping the software development landscape, offering tools and frameworks that significantly enhance efficiency and accuracy. By automating bug identification, providing real-time feedback, and predicting potential issues, AI-driven methodologies empower developers to focus on innovation and quality. Real-world examples, such as those from Facebook, Uber, and Google, demonstrate the effectiveness of these approaches, while frameworks like TFX provide a robust infrastructure for managing AI models. Despite challenges such as data quality and integration, the benefits of AI in debugging and maintenance are undeniable, as evidenced by improved code quality and reduced debugging time. As professionals in the field of AI architecture, embracing these advancements will not only enhance your proficiency, but also position you at the forefront of software development innovation.